Thank you. Yeah, so I'm taking you down into the weeds of working with data, like talking about like spaceships and data mesh. I'm like, yeah, this basically presentation is gonna be more like a bicycle riding 101. Lots of you will know, and you'll be already doing that. And if you don't, it's probably gonna give you some ideas how to handle those APIs, how to make your life easier, and basically make things more reliable. I always basically wiring things up day one. Everything is looking great, right? Things are working. You're receiving that HTTP 200 OK. The JSON is parsing. The data is flowing. And everything looks good, right? It's all going to stay like that forever. That API is going to just work from now on. And obviously, that's always, makes me think, well, I just created a problem for future me, right? This is actually helps my conversations with my kids. Like, think about your future self. Wouldn't your future self love you to brush your teeth before you go to bed? Or, it's kind of like a persona. Future me or future self is very helpful to sometimes keep in mind. So today we're gonna talk about schema-on-read. Right, so giving you some flexibility, allowing you in the future to make mistakes, things that you build to fail gracefully, and giving you some space to recover and fix things when things break. So what are the common challenges when we're reading data from APIs? And it's not just some APIs, I think all APIs can be challenging. So the shape of APIs and the results they give you can change without notification, or that notification may end up in your spam folder. Okay? They send you a notification that the API is going through a major version change, and you just missed this notification, and then your API communication breaks. The results and shapes and interpretation of fields, they're supposed to change in controlled manner, but as in with any communication, the meaning that we assign to terms, which is also true for anything we put in a schema, it can also change, right? A certain field name, one day it can mean one thing, and then the developer that put this field in may sort of imply something that we never thought it's going to mean, right? Even all the strongly defined or well-defined APIs, such as, if you remember the ways of the XML-driven APIs, WSDLs and XSDs or schemas, XML schemas, they only captured the syntactic meaning, right? The semantic meaning was assumed to be either understood implicitly or just like documented somewhere and will be completely unambiguous, which actually was never the case. So we have to prepare ourselves for this particular occasion and, kind of allow ourselves to recover from failures, allow ourselves to recover from these particular failures when APIs basically let us down. Some APIs may include dynamic or undocumented values, or values that can be assigned at runtime, so they're not even captured in the schema, right? So we tend to rely on them when we build our applications. We tend to always count that particular value will be in that JSON array or XML key value pair bag, and it may stop being the case one day, and then your API consumption simply breaks. We're also forgetting one of the main reasons why API calls or API integration is unreliable, and it's the network in the middle, right? Sometimes the network becomes unavailable. Sometimes APIs go down. Sometimes we get connection refused. Sometimes we get URL changes. We still want to be able to recover and at least have something that we were able to ingest last time we looked at the data. All right. So semi-structured endpoints, XML APIs, CSV APIs, yeah, we all seen those. Who here had to deal with PDF-based APIs? Yeah? Some of you? Well, I had. Yeah. So giving you that, like some organizations, they consider themselves doing a B2B API, B2B data integration, and they just provide you a PDF with a table in it. And that's their way of communicating their data to you. We always wish that structured data, sometimes it needs to be a bit more flexible to accommodate for certain things. And when that flexibility drops in, our API may break. Even most data with the most strictest and most sort of robust schema validation, it can change. It can eventually change. It can change over time. And sometimes it is provided, sometimes it is not provided. So how do we recover? How do we deal with all those? Right? This is where kind of we resort to generalized hair pulling, right? So this is where the parsing code breaks. This is where we realize we didn't get that payload from that particular API. We didn't capture it. We need to recover from HTTP 500 error. And this is where we genuinely sort of need to face the task of recovering our API from that particular failure. Right? We thought we already have the technology. Right? This is, these days, we thought, there should be a way, there should be a better way of handling that error, those errors. There should be a way for us to be able to ingest this data and recover from all these errors that we may encounter when we're calling APIs. So in this particular approach, there's multiples. There's more than one way to fix that. But schema-on-read in data management is essentially it's a deferral, or we're deferring applying a schema onto data that we receive only after we receive it. So we receive the data very gracefully. We read the data. We park it somewhere where we can read the data, at our own time in a local storage. I heard the name of data mesh side container being mentioned. So similar to data mesh side container. So bringing the data over, getting that HTTP 200 and not looking into the payload yet. Just get the data over, store it as string or as a binary stream in your table, and then do the parsing later. So deferring the interpretation of the received data and to that point until the data is fully read over the network and delivered and stored in the database. Okay? So that will allow us to at least take the network out of the picture, take the network failures, timeouts, payloads, partially received out of the conversation, and just have the data locally and then interpret the data at our own time, at our own leisure. Now, what is it going to give us, right? So being able to interpret the data again, give us the opportunity to apply multiple schemas, right? To evolve. Try the old schema, try the new schema, failing gracefully, go back to your failed sort of data pipeline and trying to recover it manually, then fixing our integration, taking the network out of the picture, avoiding the data loss, right? So failing only after we got the payload. So this is what schema-on-read is implied. So it's basically dealing with the data locally on the side of when we receive the data, not failing during the transmission of the data. Now, what's good about this approach? It can help us facilitate upstream schema evolution, right? So we can gracefully fail. We can always apply one schema. If it fails, we can try another schema. We can try multiple interpretations of different fields. We can report an error. We can then manually try and go back and recover. We can manage the metadata separately. We can have a collection of different different schema or metadata structures that we can then go and apply to the data set that we receive. So what is this going to look like in reality, right? So when we're ingesting responses from the API, we store them pretty much straight away once we finished receiving the payload. And we're storing it in as close to the raw form as possible, right? If you can assume that JSON, you're always going to get a valid JSON, that's fine. Yeah, store it as JSON. If you're not confident that your payload is going to be valid JSON, store it as string, right? So you can later actually unpick it maybe as a bunch of string matches. So that the meaning here is basically storing it, requesting and storing and recording it in probably let's call it a lowest common denominator between yourselves and the sending side and the API, which can be JSON or can be string, right? Once you've received the response, you store it as JSON, then this is where we're going to apply the transformation as the next step, okay? And we adjust the transformation logic as the schema changes. If we detect a schema change ahead of time, we can go in and create a little sort of case statement where we can check for the schema version or check for some sort of indication that whether, to check whether we're dealing with the old schema or new schema and apply the right version of schema to parse the data. It's always good to have the schema basically be, the schema dealing or schema indication to be part of your payload. So you can always go and, select the right schema and apply it at the time of the parsing of the schema. And then once you have applied the schema, you can parse the data set, or apply the schema or apply your parsing rule. You can actually parse the data set and you can share the data product either from a table or, from a, whatever sharing mechanism you're using. Now we have to deal with a variety of different sort of API results that we may receive, right? We've got JSON APIs, we may get gRPC, we may get GraphQL responses. OData is still around, it's still popular, especially in the Microsoft space. X12 in the B2B space, various formats. So the additional step you can implement for any structured data, often the lowest common denominator can be JSON. So translating your XML payload into the closest form in JSON can be the first step. So JSON is often a very good representation form for a structured data that you receive, okay? Whether it's XML or JSON. I'm going to go and jump into a demo and show you how we handle that in Ascend. Ascend, for those of you who don't know, is basically a data pipeline automation platform. So what you see in Ascend is, these are data pipelines. So we have 3 data pipelines that read my mythical Toasters data API. So ingesting data from 2 JSON APIs and 1 XML API, and applying schema-on-read. So applying schema-on-read using the underlying data platform transformation capabilities. So if we look at the data that we receive, let's just look at the code first. So in this particular example, we are using Python code to ingest data from the Toasters API, and at the very bottom, you see the yield statement, right? It's basically dumps. It creates a structure with 2 fields. It's when the response time was when the response was received, and the JSON of the response as a string. When we look at the records, so if we look at the records, scrolling down, you can see that alongside the timestamp, so the last step will be the timestamp, and the first step will be so basically the response payload stored as JSON, which we then can hand over to the underlying platform, to Snowflake, and really do transformation in Snowflake by applying or parsing JSON, parse JSON function. Now, all the underlying data platform these days, they can handle JSON. That's why I said JSON is a really good common format to handle, responses. Strings is it's pretty rare that you may need a string to be able to handle the responses, but the underlying data platforms can handle JSON. So in this particular case, looking at records, you'll see records representing as strings. So this is where we're just going and parsing all the required data into basically records. And then out of that particular data product, we are sharing them as records. So we've consumed the data through APIs. We've used the underlying data platform to transform the data, and then we're sharing it out as a structured data set. My second example is another JSON API, and it's just the difference is the way we actually consuming and creating the structure. We're using Spark data frames to create responses in the response timestamp data frame with just 2 fields. And again, the resulting structure is exactly the same. We've got the JSON payload, and we have the response timestamp as another column. Again, as the next step, we're going through another, so exactly the same transformation. We're simply applying a Snowflake parse JSON function to the response we received. The response getting from the local database. So we're not making we're not retrying it over the wire. We're actually parsing the data pretty much locally, taking it from a Snowflake table. Again, the resulting data set is exactly the same. We're getting parsed data set with all the fields and all the values. Again, sharing the data set. And my last example is consuming the XML data. It's actually very, very similar to the first example, the only difference being alongside my JSON string, I'm also storing my XML string, because it's always a good idea, to kind of protect myself against failures in, XML to JSON conversions. So they kind of it's easy to convert, but some of the things, sometimes it actually fails. So not all the XML structures can convert into JSON, for example, JSON arrays and XML arrays. The interpretation can be a little bit different. So I'm storing 3 fields here instead of 2. So I'm storing my JSON payload, I'm storing the timestamp when the response was received, and I'm storing the original XML payload. So we can see all that in basically the records view. So we've got the records, we've got the timestamp, we've got the JSON record, we've got the timestamp, and we have the XML string here, just in case we need to validate and reparse it and change the rules how we create JSON out of our XML. Now the next step is exactly the same like we had in the previous example. We're using the parse JSON function in Snowflake to extract the required fields from the JSON representation of the XML payload we received. And if you noticed, even though I'm sort of using XML, and if it was a SOAP web service, I'm not really using any sort of WSDL-based parsing. I'm sort of latching on or mapping individual fields from the JSON payload representation of my XML payload. Minor presenter view. So basically, to summarize that, right, it's a really sort of, I think, a well-known pattern in sort of data engineering and data integration. So consuming data and then deferring the parsing of data to a later stage, parking the payload in the database, and then applying transformations or applying schema or trying to parse the data locally without sort of necessarily going and doing a round trip to the API, because network communication is hard. Retrying connections over network is always, risky. So, and we are able to see the implementation of that particular pattern in Ascend, in data pipelines in Ascend with read connectors and the underlying data platform transformations.
No, all right. Thanks very much, Michael. Hyatt.
Thank you.